do this? What? How does this... Okay, I have no idea, bro. How do you even do this? Just ask my friend, I guess. Dude, these notes, what? What does this even mean? How do you get, like... How do you do this? How do you do this? Also, it's getting a bit dark right now. It's getting a bit dark. I mean, the light switch is just there. Do I really want to go all the way there to get it? I don't want to travel like 3 extra steps. I'm tired. 3 steps is like 3 miles to me. I don't want to walk. Is there a way to do this without walking 3 steps? Oh, wait. I have an idea. But before we go through my idea, let me give you a bit of physics. Basically, I'm going to make a switch that detects the light level outside and automatically turns on my light switch when it gets too dark. Let's see how this works. So this is our setup for our circuit that will measure the light level. What we have is basically 3 components. But one, our Arduino, which gives us a 5-volt input into the circuit, just like a battery. Then we have a resistor, which is 2 million ohms of resistance. And finally, we have this LDR. An LDR is a light-dependent resistor, or a photoresistor. That means that its resistance will change with the amount of light level it has. And what the measurement does that we're trying to measure here is that we take the voltage from this point A relative to the ground. And what that means is that we just measure the voltage across the LDR. And by doing that, if we know this voltage, and we know that the source voltage is 5 volts, and we know that this resistance is 2 mega ohms, we can find the resistance of the LDR. So let's do that really quick. We know that I is equal to V over R for the entire circuit, meaning that, and R is the value that we're trying to find, the resistance of the photoresistor. So V over R, this is also equal to 5 minus V, because we can also consider this voltage, which would be 5 minus V, since it adds up to 5, divided by 2 mega ohms. And I'll just write 2M. So now let's multiply everything together. So 2M times V is equal to R times 5 minus V. And we're trying to solve for R. So R is equal to 2M times V divided by 5 minus V. And so that gives us a way to find the resistance of the photoresistor if you measure the voltage across the photoresistor. So Arduinos don't measure voltage from 0 to 5 volts. What they do is that they measure a digital signal, and that digital signal can range between 0 and 1023. And this corresponds to a range between 0 and 5 volts. So to convert between the signal that we measure, all we have to do is multiply by 5 over 1023. So that gives us the voltage from a digital Arduino signal. And then we can take that voltage, input it into this equation, and solve for the resistance of our photoresistor. So you might be wondering what an LDR or a photoresistor is, or how it works. So here is basically what that device did in my overall device. So the top image is a diagram of an LDR, and basically this is what they all look like. They all have this squiggle in the middle and then 2 terminals on each side. The 2 terminals are just wires which you can connect to anything, and this squiggly line is kind of like a resin coating. And beneath that, you also have a ceramic substrate under everything. But the important part is this part in the middle, which is cadmium sulfide, or CDS. And the CDS is basically the semiconductor that's found in the LDR. And semiconductors are very special in terms of light and photoelectric effect and all that. So normally in an atom, let's say we have a hydrogen atom, we have a few energy levels like 1, 2, 3, 4. Let's just say we have 4 energy levels. And if you have an electron in, let's say, the first energy level, and a photon with enough energy hits it, the electron will jump to maybe the 4th energy level. And it will absorb that photon and go to a higher energy state. That's how we normally deal with the photoelectric effect. With a semiconductor, it's a little bit different. Since there's so many electrons and so much different stuff happening, you kind of get a lot of orbitals. You get a lot more. It's hard to do something for each individual orbital. So there's so many orbitals, but what happens with a semiconductor is that the orbitals get grouped. So there's a bunch of orbitals at the bottom, and there's a bunch at the top. And you can, if we go down to the diagram on the bottom, that's what we see. So here, some energy levels on the bottom, and here's some energy levels on the top. And they're both grouped. The group on the bottom is called the valence band, and the group on the top is called the conduction band. And that basically, when an incoming photon hits an electron that is found in your valence band, the photoelectric effect will still occur. That electron will absorb the photon and maybe jump up to the conduction band. When it jumps up to the conduction band, it's much easier for the electron to move around in the material, hence the word conduction. This electron becomes a conducting electron that can carry charge through the material and move wherever it wants. So as you can see, if you have light hitting an electron, that electron is able to conduct electricity. And just like the photoelectric effect, if you have a higher intensity of light, that means that more electrons will be knocked off of the valence band and go into the conduction band. So if you have more light or a brighter light, that means that more electrons are knocked into the conduction band and more electrons can move. That means the resistance of this LDR goes down, the conductivity goes up. It goes the opposite way as well. If you have less light or less intense light, that means that the resistance of this LDR will increase because there's less electrons going into your conduction band. The last major part of our device was a servo motor. So as a quick recap of what a motor is and how it works, basically you take a coil in a magnetic field as shown right here, and you run a current through that coil. Due to the magnetic force, when the field and the current are perpendicular, this coil will rotate clockwise. Like that, due to the magnetic force. It will rotate until it reaches its halfway point. In that case, it would start to rotate the other way unless you do something to make it still go in the same direction. In that case, we have this device here called the commutator. And what a commutator does is basically it reverses the direction of current in the loop every time it rotates halfway through. That makes sure that the coil keeps rotating in the same direction as the motor keeps spinning. So commutators help the motor to keep rotating in the same direction. So that's how a motor works. Basically, a servo motor is a special type of motor that you can control to reach any angle that you want to reach. So you could say servo rotate to 90 degrees and it would rotate to 90 degrees, or you can make it to rotate to 75 degrees or 30 degrees or 180 degrees. And the way it does that is it uses feedback. Namely, it has an encoder for the angle it has. Basically, if it rotates 181 degrees, it knows that it is 1 degree off of 180. And it uses that feedback to rotate it back in the opposite direction, back to maybe 179 degrees. And then now you've overshot it, so go back to 180 and keeps going back and forth until it reaches the correct angle. So maybe the motor is at 90 degrees right now, and you want to rotate it to 45 degrees, as with the dotted line. So first, the motor would start rotating this way, but then it gets feedback that it's overshot, and then starts rotating this way, and then starts rotating this way, until it reaches the correct location, which is right here. So that's how a servo motor works, and basically you can make it to rotate it to whatever precise angle that you want. And that's how we use a motor to flip our light switch. Now let's see our final device. I took away my laptop, but it would be plugged in using this cable to the Arduino. The laptop is what provides 5 volts input to the Arduino, which the Arduino then transfers to this breadboard using this red wire. This wire is connected to these 2 resistors, both of which are 1 million ohms, so they add up to 2 million ohms. And then I have a jumper running up here to my photoresistor. Then I have another jumper going back down here into this yellow wire, which goes into our ground or our negative terminal of our Arduino. I also have 3 wires coming out of the Arduino and into this servo motor, which is what turns on our light switch. Our servo motor is connected to the wall with some tape, but it's also glued onto a few things. So you can see that this light switch, it's a little bit extruded from the wall. So we had to put a piece of foam in between the motor and the wall so that everything's level. And then the foam is glued to the wall, the motor is glued and taped to everything. This is pretty hard to pull off, putting it in the correct location. Then we also have this little cutout popsicle stick that's clipped onto the arm of the motor. Since we're extending the arm of the motor, you get more leverage when you hit the switch, because torque is force times lever arm, and if you increase the lever arm, you can increase your torque. So that is how we constructed our device and how it works. And our last part of our project was our code. Now I'll just walk you through it. It's pretty simple. All we do is first set up a servo and initialize the servo to 135 degrees. That would be kind of the light switch in the off position. Then I have these 2 functions that basically use the mathematical relationships we've already talked about. For one, this voltage function converts our digital signal into an actual voltage from 0 to 5 volts, and this resistance function takes a voltage input and turns it into a resistance using the same Ohm's law relationship we talked about earlier. Then in our loop function, we basically, every 10 seconds, the Arduino will measure the resistance of the LDR. And if our resistance gets greater than this value, which is around 3 million ohms, we will turn on the light switch by turning the servo to 70 degrees, waiting a second, and turning it back to 135 degrees. After which we'll just stop the program by delaying for a really long time. So that's how our program works and how we turned on a light switch using our Arduino. And now let's see our device in action. This is going to be good.
Let's go.